Now let's see what is an Electron application composed of. So since the front end of the application or the UI of the application is developed using HTML, CSS, and JavaScript, Electron uses Chromium to render this front end. But since Electron applications run on operating systems like Windows, Mac OS or Linux, so it needs to do some system operations as well, like to operate or handle files or call some system APIs and so on. And this is not a write a code or initialized our npm. Then we type Electron, which is the name of Visual Studio Code, and import some modules from Electron first. We want to check if we create the course. The renderer process is responsible for rendering the HTML, CSS, and JavaScript files of the front end or the UI of the application. So we didn't add any HTML or JavaScript or CSS files yet. Okay, so this is the time to do that now, to display the UI of the application. So let's start with the HTML file. Okay, so I'm gonna create a new file called index.html. Then say do instance. Here we store the and pass to run the application. We can see also the data. So now we can see the span displayed, and we can see also the title of the application has been set to screen capture. So we loaded the HTML now in our application. So now we also would need to add some CSS code to this application to style it. So let's create a file called styles.css, and then let's go back to index.html and include this file here using the link tag. Okay, so I'm gonna set the href attribute to styles.css in the current directory and the rel attribute to style sheet. Now we loaded this CSS file in our index.html. So let's add some styling just to test the application. Alright, so I'm gonna just change the background of the body to blue. Okay, now if we start the application, we can see that the background has changed. Alright, so each time we do a change in our code, so for example, if we remove the background color, okay, we have to restart the application, right? And we have to go to the command line, close the application, and start it again. And this might consume some time, so we can avoid this by installing an external dependency called nodemon. Alright, so this is a package that will monitor all the files of the project. If any of the files change, then it will reload the application and restart the application automatically. So we don't have to do it manually. So to install this external dependency, we can basically do the same thing as we did with Electron. So npm install and also --save the -dev, because this is development dependency. Then the name of the dependency, which is nodemon. Okay. Then that's it. Hit enter, and after it's installed, you can go back to package.json. You will see it in the dev dependencies here as well. So we have to modify our start script to use nodemon instead of Electron. Okay. So let's type nodemon, then space, then --ext. So this means watch for these extensions of for these files extensions. So we want to watch JS, CSS, and HTML extensions. If any code changes happen to these files, then we reload the application. Okay, let's type --exec, or this is an abbreviation for execute. Alright, so that means execute this command when a code change happens in files with these extensions. Okay, so the command that we want to execute is electron. Okay, so electron space dot, that's the command to start electron. Alright, so now if we go back to the command line and type npm start, as you can see now nodemon started this application. And now if we go and make any change to any of the files with extension CSS, HTML, or JavaScript, so for example, let's set the background color again to any color, blue for example, and if we save the file, you can see that the application was restarted automatically. Okay, of course this is very useful during development to see our code changes directly without having to do this manually. All right, so now let's continue with creating the UI of the application. So let's go back and let's go to the HTML code and add here a div and set its class to navbar, and add the span in this div. So this is gonna be a navigation bar for our application. All right, we're gonna remove the default navigation bar and use this as a navigation bar. All right, so let's also create a new folder and call it assets. We are going to add our images here. All right, so since we are developing a screen capturing application, so this application will allow us to click on a button and capture the current screen, all right, as a screenshot, and save this to a file. All right, so it will save the screenshot to an image file. So we won't need a button, all right, to be able to click on it and capture the screen. I'm going to use this camera image as a button, so you can download this from the link in the description of the video. Okay, and add it to the assets folder in the project like that. All right, so now let's go back to the HTML code and let's add another div and name it container. All right, and we are going to add the button inside this div. So let's add an image. This will represent the button. Actually, it's an image, not a button. But we are going to use it as a button. Okay, and let's set the source to the path of the camera.png file. And now, as you can see, this is how it looks like. So we want to reduce the size of it and also center it in the middle of the window. All right, so to do that, let's do some styling of the application. Let's go back to styles.css, and for the body, let's set its width to 100 VW, so that means 100% of the current screen. All right, and the height also to 100 VH, that means 100% of the current screen height. Okay, so Now we make this application, or we make this window consuming the full screen size. Alright, now let's style the class of the nav bar. Okay, so this is the navigation bar. We want its height to be 50 pixels, and let's set its background to gray, and the color, the font color, to white, and the width to 100% to make it 100% of the screen width, and the position absolute, because we want to keep it always on the top, right? So let's set the top to 0, and also to the leftmost of the screen, so let's set the left attribute to 0. Let's set the display to flex, alright, because we want to align or center vertically the title in this navbar. So let's use align items to center. Let's set align item to center to do that. And let's also give it some padding, some left padding. So let's set the padding left to 10 pixels and the font size to 20 pixels. And that's it. So now if we save, you can see that this is how the navbar looks like now. But we want now to remove the default navbar and also the default menu that is created by Electron. To do that, we can configure the browser window instance that we created using an options object that we can pass to the constructor. And we want now to remove the default navbar and also the default menu that is created by Electron. To do that, we can configure the browser window instance that we created using an options object that we can pass to the constructor. This is an optional argument, so that's why we didn't pass it, and this is fine. But if we want to configure arguments, an options object that we can pass to the constructor. But if click on Alt, we can see this option, this browser window constructor. Alt and click on it, and you can see all the configuration options that, and this is by default. So let's go back to main.js and pass this options object here to the browser window constructor and set frame to false. If we save, now you can see that the frame is not there anymore. All right, but now we cannot drag the window anymore, right? Because we used the default frame of the window previously, or the default navbar, to drag the window. Now we can't drag it anymore, but we have our custom navbar and we can use it to drag the window. So we have to set an CSS attribute to do that. Let's go back to the styles of the CSS file and add this CSS attribute. So dash webkit dash app dash region, all right, then column, okay, then drag. So that means any item with this class will be able to drag the window. In this case, the navbar only, alright, will be able to drag the window. If we go back now to the application and drag the window using this navbar, you can see that it drags the window normally. So now let's also make our window transparent, just to make only the camera button visible and the navbar, alright. So let's go back to the browser window constructor and pass a transparent attribute and set it to false, set it to true, excuse me. This will make the window transparent, as you can see. But we still see this scroll bars. This is a very common issue in Electron. We can remove this using CSS as well as a workaround. So we can set the overflow to hidden for the body tag, okay? So let's go to styles with CSS and set the overflow attribute to hidden. And now if we save, you can see that this is how it looks like now. So now what's remaining is to center this camera button in the center of the window and also make it smaller. So first let's all right, and also we don't want 2 seconds. So that means this animation will happen on 0.2 seconds, okay, or during 0.2 seconds. So now let's add this animation actually. So we want to do this for the hover event when we hover over the camera. So let's add here the transform to scale and pass here 1.1. That means make this image 1.1% larger than actual over it. Start to flex, and then we can use a justify content size of so with UI of the application per process. All right, so now we are done with the render process, all right, and also the main process, all right, because we implemented the UI of the application and main.js, all right, which is representing the main process in our application. So now the remaining part is the communication between those two processes. Okay, so whenever we click on the camera button, all right, we want to capture the screen and save it to a file. But as we learned from the render, we cannot do this because we don't have access to the system APIs.
Yo mas, yo, mobilan semua besok, masuk mobil semua besok.
Or any Electron or Node APIs. So what we want to do is we want to send a message to the main process to tell it that we want to do this. All right. So as we learned, this communication happens through IPC. But first, we have to have some JavaScript code in the render to be able to handle the click on this camera button and then send the message to the main process. So let's create a file, a JavaScript file, and name it render.js. So this is gonna represent the render process, okay, the JavaScript code of the render process. And now let's add a script tag here in the index to HTML to load this script. All right, so let's set the source to the path of the file, which is the current directory, then render.js. And now let's go to render.js and import some modules. So we are going to import a module called IPC render from Electron. This module will allow the render process to use IPC to communicate with the main process, okay? So as you can see, when we imported this module, there is an error that says require is not defined, because by default, Node is not allowed for the render process, and the render cannot use Node APIs, as we learned, okay? So sometimes during development, it's okay to enable Node, all right, for the render, to make Node available for the render, but that's not recommended for production, okay? But for now, let's just enable Node for the render. We can configure this from the options object that we pass to the browser window constructor. So we pass an object called web preferences, okay? And in this object, we set the context isolation to false, and we node amended node allows process. Then render.js. And now let's go to render.video node Node is not allowed for the render process, and the renderer cannot use Node APIs, as we learned. Okay. Node function. So we pass an object called web preferences, okay? And in this object, we set the context isolation to false and node integration to true. So that means we enable Node for the render, all right? And now the render can use Node.js syntax, okay? For the render. All right, and now that error, and now we can use it to communicate with the main process and send a message to it, okay? But before that, let's just make sure that the render is working properly. To render error anymore. All right, Node.js. That means we set, so we can configure this from the options object that we put. Okay, can use Node. Right, so now we imported the IPC. Render module from Electron in the render, and now we can use it to communicate with the main process and send a message to it, okay? But before that, let's just make sure that the render is working properly, and let's just display an alert, all right, and say hello from the render and see if this will be executed successfully. So let's save now, and as you can see, the alert is displayed, so that means the render is working as expected, okay? So now we can send a message from the render to the main process using the IPC render.send, so the send function. And the first argument of this function is the channel. So this is the name of the message, in other words, all right? So we can name it capture dash screen, okay? So now we send this message to the main process from the render process. But we don't just want to send it anytime like this. We want to send it only when we click on the image button. So first, let's set an ID to this image button. Okay, let's call it camera dash button, and let's listen to the click event here using document.getElement by ID first to get this element. element, and then we use add event listener, the event name, and then the second argument is a copy that, but we main process and import a module called IPC main. So this will allow the main process to use IPC to send messages from the main process to the render process, or to handle messages sent from the render process to the main process. Okay, in this case we want to handle a message. We can use IPC main.on. all right, that means on, or when this message is received, do something. So the first argument is the message name. Okay, so in this case capture dash screen, and the second argument is a callback function, all right, that will be executed or invoked when this message is received. All right, so for now, just for testing, let's log something on the console. Let's say handling capture screen, and let's go back and click on the camera button to test this. All right, and as you can see, there is an error, cannot read properties of null. Okay, the reason is we are trying to get an element by ID, and we loaded the script before actually creating that element. All right, so our workaround for this is just adding the script tag after that element. All right, so at the end of the body tag here. Okay, so now if we save that and go back and click on the camera button, we will be able to see the message here logged. So now that means the communication between the main process and the render process is done. Here logo body tag. So adding is, and as you can see, go back and click on the camera button to test this. Right, and as you can see, there is an error, cannot read properties of null. Okay, the reason is we are trying to get that element. All right, so at the end of the body tag here. Okay, so now if we save that and go back, so now that means the communication between the main process and the render process is done or happening as expected. All right, so now let's do the actual implementation, which is capturing the current screen and saving it to a file. So let's delete that console.log line. We don't want it anymore. And to be able to capture the screen, we need to import two modules from Electron. The first one is screen. So this will provide some information about the current screen, okay? And desktop capture, which will capture the current screen, okay? So after importing these, let's start the implementation. So the first step is getting the current screen size. So let's create a constant, call it screen size, and use screen.getPrimaryDisplay, display, okay, to get the current primary display for or the current primary screen, okay, and use the attribute work area size. So this will retrieve the size of the current primary display, okay. All right, so the second step is to retrieve the thumbnails, all right, or the images of the current screens, okay. We can do this using the desktop capture module. So let's create a constant, let's call it screens, okay, and assign it to this. First we type the await keyword because this is an asynchronous function, and the function is desktop capture dot get sources. So this function will resolve a promise with an array of desktop capture source objects. So each of them represents a screen, okay. So we have to pass an options object to this function, okay, and this object has an attribute called types, all right, which is a list of the types of sources we want to retrieve. So we want to retrieve screens, right? So we type here only one item, which is a string, which is a screen. And we can also set the thumbnail size. So this is the screenshot size, right? So we have already the screen size. We retrieved it and stored it in the constant screen size. So we can set the width of the thumbnail size to screen size.width and height to screen size.height, okay. So now we configured the desktop capture and we retrieved the current screens, all right, and store them in this constant, all right. And we also configured the thumbnail size. That means that we configured the screenshot size, and now this screens list has all the current connected screens. So in this list, the primary screen is always the first one. So we can retrieve it from the screens array using the index 0, okay. Then if we want to retrieve the image or the screenshot for this screen, we use the attribute thumbnail, okay, and we store this into the image constant. But first we have to convert it to PNG, all right, to convert it to a PNG image. So we have now this image data here stored in this constant. So the next step is actually saving it to a file. We are going to use the current timestamp to make the file name unique, okay. So let's create a constant, call it timestamp, and assign it to a new date instance, then call to isostring to convert it into a string, and then let's also use this replace function to replace any dots in the file with dashes, because we cannot have dots in the file name, okay, because dot is used for the extension of the file. So we have now the timestamp, and we want also to append or prepend something to the file name, so like a screenshot, for example, all right. So let's create another constant, assign it to screenshot, then dash, then the timestamp, then we append the timestamp, all right, then the extension, which is .png. So now we have the complete file name. So the remaining part is having the complete file path, okay. So we are going to use the path module from Node, okay, to be able to create a path that's compatible for any operating system, okay, so whether Linux, Windows, or Mac OS. So after importing path, let's use path.join, okay, and join current directory. So we can use the current directory in the code using double and join current directory. So we can use the current directory in the code using double underscore their name, okay, and we join this with the file name, So now we have the complete file path, which is the current directory followed by the file name. Okay, so the remaining part is actually creating that file and storing the image data in it. So we use the fs module from Node to create files and write to files. So let's import it, and let's use the write function from the fs files and write to files. So let's import it, and let's use the write function from the fs module to write to this file. So the first argument is the file path. Okay, so let's pass it, and then the second argument is the data of the file. So let's pass image. Then the third argument is a callback function that will be triggered after writing to this file. So it takes one argument, which is error, in case if there is any error with writing to the file. So what we care about is that this function will be called after writing to the file, and we want to actually open this image using the default image opener in the operating system. Okay, so to do that, we use another module from Electron called shell so make sure to import it as well, and then we use the open external function from that module to open a file using its default Electron called shell okay, so to do that, we use another module from Electron called shell so make sure to import it as well, and then we use the open external function to files file. So let's import it, and let's use the file path file. It will be with writing to the file. Then the third argument is a callback function that will be triggered after writing to this file. So it takes one argument, which is error, in case if there is any error with writing to the file. So what we care about is that this function will be called after writing to the file, and we want to actually open this image using the default image opener in the operating system. Okay, so to do that, we use another module from Electron called shell so make sure to import it as well, and then we use the open external function from that module to open a file using its default application configured for opening this extension in the operating system. Okay, then we pass the complete URL of this file. So in this case, file, then column, // then the file path. Okay, that's it. So after the file is created and the data is written to it, we are going to open the image using the default image opener in the operating system. Let's save and let's try the application now. So if we click on the camera button, you can see that the screenshot is taken and also saved to a file, and the file was opened by the default file opener. All right, so now everything is working as expected. You can see now the screen